chain rule works with trig as well, but sometimes it's nice to just kind of see it all written out in this form. So these are the quote chain rule versions of these trig functions. Remember taking the derivative of something like sine x, that's easy. That's just cosine x. But once you put in something like sine of 2x or sine of x plus 2, you are required to use the chain rule. First of all, we need to decide what is their outside function and what is the inside function. That's pretty easy with trig. Trig is usually the outside function, and whatever you're taking the trig function of is the inside. So 2x will be our inside function, and then sine will be our outside function. I'm going to write this as u is equal to 2x, and then I'm also going to find u prime is, that's just 2. So to find y prime, the derivative of sine of u is cosine u times u prime. We have a value for u, so let's substitute that back in. Y prime is equal to cosine of u, cosine 2x, and that's being multiplied by u prime, which is 2. That 2 is going to become a coefficient. It's not inside of the cosine function. So y prime equals 2 cosine 2x is the derivative of sine 2x. Our next one is cosine of x minus 1. So our inside function is x minus 1. Our outside function is cosine. Let's actually call this u. U is equal to x minus 1. And then what is u prime? That is just 1. Our derivative there is negative sine u times u prime. So we would take negative sine of u, which is the inside function x minus 1, and multiply it by the derivative of u, which is 1. And that's our answer. The inside function is 3x, the outside function is tangent x. I'm going to say u is equal to 3x, which makes u prime equal to, okay, the derivative of tangent is secant squared u times u prime. So y prime is equal to secant squared u, which is the function 3x, times u prime, which is 3. So 3 now becomes my coefficient in the front. 3 secant squared 3x is my answer. Let's review some notation with trig and what these actually mean. So, and then we're going to derive them. So y equals cosine of 3x squared is literally saying we're taking the cosine of this product, 3x squared. Cosine 3 times x squared, that is literally a product. When the little 2 is on the outside, but the cosine or the trig function is not inside of some sort of brackets or parentheses to the power of 2, that means that little 2 is not applying to the cosine, it's only applying to what you're taking the cosine of. So we could rewrite this as cosine of, let's apply this little 2. So 3x squared is 3x times 3x, which is 9x squared. That's what you're taking the cosine of. Here, cosine squared x, you are a little bit more familiar with this one. It's just taking cosine x and squaring the whole thing, but avoiding having to write it in parentheses. And then the square root of cosine x any root can always be rewritten as an exponent, which is almost always preferred for derivation. This would be cosine x to the power of 1/2. Let's derive these. The inside function is 3x squared. The outside function is cosine. The derivative of cosine u is negative sine u times u prime. And u in this case is 3x squared. So the derivative here would be negative sine of 3x squared times the derivative of 3x squared, which is pop down, power down, 6x to the 1. Y prime equals, bring the 6x as your coefficient, so negative 6x sine of the product 3x squared. To derive part B, we must remember that cosine of 3 is just a number. It's just a constant. So guess what? You don't have to use the chain rule. Y prime is equal to, okay, so if this is just some number, it's like you can block it off in your head. And it's going to be multiplied by just the derivative of this constant multiple rule. So what is the derivative of x squared? 2x to the 1. And that is being multiplied by our number cosine 3. Or you can write it as 2x times cosine 3, so you don't have stuff after the cosine that is not being, that you're not taking the cosine of. Either way is fine. This one is cosine of 9x squared, so 9x squared would be our u function, and y prime is equal to negative sine u times u prime. We've already done this. So y prime is equal to negative sine times 9x squared, negative sine of 9x squared times the derivative of u. What is the derivative of 9x squared? Pop down, power down, you get 18x to the 1. Just go ahead and clean it up by bringing 18x to the front, so negative 18x times sine of 9x squared. You can put parentheses around the 9x squared, or you do not have to. This one's a little tricky because so far, whatever you're taking the trig function of is always the inside function. But because this can be rewritten as cosine x, all of it being squared, because this little 2 in between here means that the entire cosine x is being squared, that makes cosine x the inside function, and it makes the power of 2 my outside function. These will look kind of like the other examples. So y prime is equal to the derivative of the outside times the inside. Okay, so we're subtracting 1 from 2, which is 1, times the inside. This stays the same every time, times the derivative of the inside. If you don't want to think about it in this step, you can just write the derivative notation and then evaluate it in the next one. Okay, 2 cosine x times the derivative of cosine x is negative sine x, which simplifies to negative 2 cosine x sine x. For this one, we rewrote it as a power, so you had cosine x to the power of 1/2. Again, the trig function is the inside function, and the power or root is the outside function. So we'll derive similar to the way we did before. Pop down. So the derivative of the outside times the inside times the derivative of the inside. One half cosine x to the negative 1/2, that'll end up going into the denominator, times the derivative of cosine, which is negative sine x. Go ahead and clean it up by writing what is in the numerator and what's in the denominator. And we get a negative sine x in the numerator, and a 2 and a cosine, okay, and a square root cosine x in the denominator. We're going to try one more example. This one, kind of tricky. I'm going to begin by rewriting the cube part on the outside, since that helps me when I'm doing chain rule. So this would be sine of 4t cubed. Wait, is there a double composition happening here? So you've got the 4t is inside of the sine, but the sine is inside of the cube. So what do? Double chain rule. So my first inner function is sine of 4t as an entire thing. Then we'll do the sine and 4t separately later. The outside function is being cubed. So that's what I'm going to start with. F prime of t is equal to the derivative of the outside times the inside times the derivative with respect to t this time of the inside. We've got some more derivation to do. 3 times sine 4t squared is going to be multiplied by the derivative of sine 4t. At this point, my inside function is 4t, and my outside function is sine. Sine of u, the derivative of sine of u, is equal to cosine u times u prime. So the derivative of sine 4t would be, we label 4t is our u function, so cosine of 4t times u prime. What is the derivative of 4t? 4. Now we just have to clean it up and we're done. F prime of t is equal to, everything is a product, so we just need to rearrange so it looks nice. 4 times 3 is 12 times sine of 4t squared, which I'm going to write as sine squared of 4t, times cosine of 4t. And that's your answer.